In the last lecture, mole concept part 3, we were dealing with numerical problems. We shall add more to this list. For example, question is calculate the number of atoms of elements present in 5.3 grams of anhydrous washing soda. Anhydrous washing soda. Calculate the number of atoms of elements present in this amount of anhydrous which does not have any molecule of water of crystallization. This washing soda is sodium carbonate with 10 molecules of water of crystallization. So anhydrous, N means without. Anhydrous is Na2CO3. This water has evaporated. Its molecular weight 23 into 2 plus carbon 12 plus 16 into 3 46 12 48 and this is 106 atomic mass units. Weight of anhydrous washing soda, it is 5.3 grams. It is 5.3 grams. ਤੇ ਫਿਰ ਇਹਦੇ number of moles, weight over molecular weight, 5.3 over 106, 0.05. We may write 5 into 10 raised to the power minus 2. Minus 2. Decimal is followed by 2 digits. So it is 10 raised to the power minus 2. 1 mole of sodium carbonate, it is 106 grams. It is 6.02, 10 raised to the power 23 molecules. Now, atoms of elements all, sodium, carbonate, carbon and oxygen. One molecule has 2 sodium atoms. 1 mole will have 2 into 6.02 into 10 raised to the power 23 sodium atoms. It will have, molecule has 1 carbon atom. So Avogadro's number of carbon atoms. And last of all, 1 molecule has 3 oxygen atoms. 1 mole will have 3 into 6.02 10 raised to the power 23 oxygen atoms. We can make a slight shortcut, which is mathematical point of view. Number of atoms are in the ratio 2:1:3. Let us calculate the number of carbon atoms. Double will be the number of sodium atoms. 3 times will be the number of oxygen atoms. It will save our labor and in competition it will save our time. We shall calculate the number of carbon atoms in 5 into 10 raised to the power minus 2 moles of sodium carbonate. Number of carbon atoms in 5 into 10 raised to the power minus 2 mole. This will be equal to number of carbon atoms. We have this 6.02 into 5 into 10 raised to the power minus 2 into 10 raised to the power 23. It will be 30.1 into 23 minus 2, 10 raised to the power 21, or 3.01 into 10 raised to the power 22. This is the number of carbon atoms in 5 into 10 raised to the power minus 2 moles, or 5.3 grams of washing soda. It is 5.3 grams of washing soda. Making it as a base, we shall double the number of atoms for sodium, triple the number of atoms for oxygen. A simple phenomenon, a simple phenomenon. Similarly, the number of sodium atoms is equal to 2 into 3.01 10 raised to the power 22, 6.02 into 10 raised to the power 22, and the number of oxygen atoms, 3 into 3.01 into this, 9.03 into 10 raised to the power 22. This is the shortened solution to this problem, not shortened in respect of chemistry, but in mathematics. We have maneuvered the calculations to save our time in examinations, particularly in competitive examinations. So this is how we attempt such problems from elements, from compounds, correlating different elements, correlating different molecules, and extending the concept of moles to number of atoms of different elements present in one molecule. I gave you one assignment. Before that, I would like to add one thing. Anhydrous sodium carbonate is also called soda ash. An additional anhydrous, which does not have any molecule of water of crystallization, sodium carbonate, is also called soda ash. I may put another example to it. COOH, COOH, 2H2O. This is called hydrated. Common name is oxalic acid. But COOH, this is called anhydrous oxalic acid. Anhydrous without any molecule of water of crystallization. So this is a generalization in this topic. We come to a question you should attempt yourself, and that question is, calculate the number of atoms or elements present in 1.5 8 grams of hypo. Washing soda is common name for sodium carbonate. This must be a common name for some compound. So what is this? Hypo. Without writing this formula, we can't calculate its molecular weight. And without molecular weight, this information is useless. So we have to find out what is this hypo. This hypo is sodium thiosulfate. Hypo, it is sodium thiosulfate. Sodium sulfate is Na2SO4. This is sodium sulfate. But it is sodium thiosulfate, and thio stands for sulfur. One sulfur atom will increase at the cost of what? Oxygen. So it becomes increase in sulfur. It is thio. To balance or to maintain the different valencies of sulfur, one oxygen has to go. So it becomes sodium thiosulfate, that is Na2S2O3. Additional information: sodium sulfate has anion sulfate. It is a topic of 12th class. Sulfate, its structure is tetrahedral. O, this is O, this is O, and this is O. Sulfur carrying 4 oxygen atoms, its valency is -2. In this case, it is showing covalency equal to 6. We shall study it in the chapter on chemical bonding, as well as 12th class we shall study it in group number 16 of the periodic table. But at this level, it is a sulfate, it is divalent, negative valency is Ni. Sulfur is bonded to 4 oxygen atoms, 2 through double bond, there is no charge here, 2 through oxygen atoms, and there is negative charge here and negative charge here. So increase in the number of sulfur atoms, here it will be sulfur. The thiosulfate S2O3, it is sulfur, O, this is S, this is O negative and O negative, it is S2 and O3, negative charge carried by oxygen. So this is how we have an additional information, difference between sulfate anion and thiosulfate anion. Sulfur shows valency 6 here, highest covalency of sulfur is 6, highest covalency of phosphorus is 5, and so on. We shall come to this topic later on. So it is sulfate and this is thiosulfate. Sodium sulfate, I refer to it as Glauber's salt. Sodium thiosulfate, it is known as hypo. Now it is very clear. You know atomic weights of sodium, sulfur, oxygen, find its molecular weight. Weight is given. Weight, molecular weight. You shall find the number of moles. 1 mole of hypo has 2 into Avogadro's number of sodium atoms, 2 into Avogadro's number of sulfur atoms, 3 into Avogadro's number of oxygen atoms. You can use it from the given number of moles, weight over its molecular weight, and find out the number of sodium atoms, sulfur atoms, oxygen atoms. So this you may take as an assignment. Calculate. We shall move on with a little more details. We have mole concept, mole concept applicable to ions. Mole concept as applicable to ions. Definitely, we shall select some ionic compound for this purpose. Say we have potassium nitrate. This is potassium nitrate. When dissolved in water, AQ stands for aqueous, means potassium nitrate in aqueous solution will break here. Potassium cation separated, nitrate anion separated. This is K positive and NO3 negative. This is a molecule. K positive is cation, nitrate is anion. One molecule has given one cation, one anion, that is total 2 ions, and 1 mole will give rise to 2 into Avogadro's number of ions. In total, Avogadro's number of cations, Avogadro's number of anions, 2 into Avogadro's number of ions. This was an example. We may attempt a problem, calculate the number of anions in aqueous solution of 1 mole of potassium ferrocyanide. Potassium ferrocyanide. Potassium cation, ferrocyanide is the anion. Let us write their formula and then finally the potassium ferrocyanide. It is K, valency is 1, FeCN 6 times, square brackets, its valency is 4. It is 1 positive, it is 4 negative. Crossing the valencies, it becomes K4 FeCN 6 times in square brackets, because anion has small bracket, that is parenthesis also. This is the formula of K4 FeCN 6 times. It is potassium ferrocyanide. Dissolve it in water and we get potassium cations, ferrocyanide anions. Still incomplete, K4. So it is 4 potassium cations and 1 ferrocyanide ion. According to our query, we are to calculate the number of anions. We will extend it to cations also and total ions also. One molecule produces 1 anion, 1 mole will produce Avogadro's number of anions. One molecule produces 4 cations, 1 mole will produce 4 into Avogadro's number of potassium cations and total 5 into Avogadro's number of ions. 1 mole of K4 FeCN 6 times potassium ferrocyanide K4 FeCN 6 times produces 6.02 10 raised to the power 23 anions produces 4 into 6.02 10 raised to the power 23 cations, and finally 4 plus 1 equal to 5 into 6.02 10 raised to the power 23 ions. This is the concept extended to the formation of ions and so on. We may attempt a proper question. Calculate the number of ions in aqueous solution obtained by dissolving 1.04 grams barium chloride in water or in excess of water. Barium chloride amount is 1.04 grams is dissolved in water, and it will ionize into barium cations and chloride ions. We are to find out the total number of ions in the aqueous solution. The dissociation, first of all ionization and then dissociation. Barium chloride in aqueous solution. Barium may be this cation and 2 chloride anion. This is one molecule. This is one cation, and these are 2 anions. That is, there are 3 ions per molecule. Molecular weight of barium chloride. Atomic weight of barium is 137. Chlorine 2 into 35.5. 137 plus 71. This is 208 AMU. Number of moles of barium chloride. Weight over molecular weight. It is 1.04 over 208. What shall we do? It is say 5 into 10 raised to power number 10 raised to power minus 3 volts. Separately, we will discuss how these calculations are made quickly, fatafat. We shall discuss, but separately, not at this stage. 1 mole of barium chloride, 3 into 10, 6.02, 10 raised to the power 23 ions, 5 into 10 raised to the power minus 3 mole, 5, 10 raised to the power minus 3, 6.02, and 10 raised to the power this. It is 9 into 10 raised to the power 21 ions. As promised, we shall discuss the calculations in a separate lecture. Let's say it was 10 raised to the power 23 minus 3, 20. What is more? 5 into 3, 15 into 6, 90. So it was 90 into 10 raised to the power 20. So instead of 90 into 10 raised to the power 20, I have done 9 into 10 raised to the power 21. So this is the simplified. You have to shed your dependence on calculators. These will not be allowed in competitions or in annual 11th and 12th examinations. So why not start it just now? Put down your calculators and try to calculate or make a habit of calculating without the calculator. It is not difficult. Use your reflexes sharply. How to move? These digits are multiplied separately. Leave this point 0. We have nothing to do with it. Leave this, make it 6 into 3, 18 into 5, 90. 10 raised to the power 23 minus 3, 10 is per 20. What we get? 90 into 10 raised to the power 20. This goes there. So it is 9 into 10 raised to the power 21 ions. It is as simple as it is. I give another question as assignment. I gave question A, lead pencil dot. Dot means this is dot. With the lead pencil, we make a dot. Weighs 0.01 milligram. How many atoms does it have? How many atoms does it have? Should I add a question to it? Calculate the number of atoms, molecules in 4 grams of helium. Calculate the number of atoms and molecules in 4 grams of helium. I will not give any clue. You have to use your instincts or knowledge from your previous class, say 10th or 11th class. So these questions, and one question about hypo I gave you before that. So there is an assignment of 3 questions. Just solve it. Almost this topic is discussed, the topic of mole concept. We will move on the general concepts in inorganic chemistry, and we shall discuss the laws of chemical combination, law of conservation of mass, law of definite proportions, multiple proportions, and reciprocal proportions. How these different laws give us extensive knowledge of the chemistry or different combinations and permutations. Say goodbye.